morning, everyone. So this morning we're going to try something a little bit different to the previous couple of videos I've uploaded. This is going to be a video about gradients. So this comes under sort of second year linear relationships towards the end of it, but also leads into the start of the National 5 course for third years and for fifth years. So this is relevant to lots of different people. I know some of you have already learned this before, but I just want to do this as a wee upload to see if it's easy for you to follow, so that when we come to do new videos for new topics that we haven't taught you yet, I can take some advice and take some tips from anyone as to what's easier to kind of use in the future, if you like. So now that we're going to try and do this like a note, okay? So we're going to start, and the thing is, I need you guys to be able to take notes at the same time as me. So in your notes jotters, okay, I want you to put gradients down as the heading. First of all, we want to talk about what gradients are. Now, where do gradients exist kind of in real life? I've seen signs before. Now, you don't need to write this down necessarily. When you see road signs, and you might see a sort of a wee line on it like that, and it might say something like 30% or something, and then there's maybe a wee exclamation mark above it. That's telling you that that particular road, this might be up in the Highlands somewhere, this might be somewhere where there's just lots of hills, etc. That's just telling you that road is particularly steep, okay? And this number here they've come up with, this 30%, is sometimes a measurement of gradient. So that's one of the things that we're looking to try and do. We're actually looking to calculate a gradient so that we can sort of measure the steepness. So gradient is a measure of how steep something is. Okay, now it's not necessarily always going to be a line. It can be lots of different things. It can be a hill, it could be a road, it could be a pavement, it could be anything at all, really, if you're talking about how steep it is. But gradient is a measure of how steep something is. Now, particularly for us, what we're looking to do is measure the gradient of a line. Now, the line can represent lots of different things, but essentially to start with, we're going to just be calculating how steep a line is. So we want to be able to calculate or find, sometimes it says find the gradient, or find the gradient of a line. Now, a little bit of background first of all before we actually get into the kind of calculation, if you like. Here's a couple of just normal x and y axes. Okay, now I'm going to draw a lot of different lines on here. Annoyingly, my ruler, I can't find a ruler, so I'm having to kind of adjust and use this. But let's say I give you a couple of lines, right? There's one, there's another one, and here is a third line, okay? Now these lines have all got different steepnesses, if you like. These ones have also got different steepnesses, but have got something quite different, okay? These ones here are all said to have positive gradients, and these ones have negative gradients. Okay, the steeper a line is, so this one here, for example, if I put a wee star beside that one's the steepest positive gradient. That would have a number that's quite a large number. That might have a number that's, say, 2 or 3 or 4, etc. Quite a relatively high number. On our negative ones, this one would be the steepest one that's going down the way, or negative gradient. And again, that would have like a number that's 2 or 3 or 4 or 5, etc. This one is the least steep in the positive direction. This one might have a fraction as a gradient. It's probably going to be like a half or 2/3 or a quarter, etc., etc. And the same with this one here, except it would be going down the way, so it would be negative. And then the ones in the middle here are supposed to be approximately 1, and then similar over here, this would be approximately -1 going down the way. So anything that's steeper than this type of line here has a number that's sort of larger than 1, and then anything that's less steep is a number that is going to be a fraction probably. It could be a decimal as well, but it's going to be less than 1. Okay, so that's the difference between positive and negative gradients. Now, to actually calculate a proper number, because you can't just turn around and say, oh, I think that's about 2 or 3 or 4 or 5. We need to have a way of actually kind of calculating it. Now, when I do this in class, I do have lots of different ways, or a better way of showing you this, but unfortunately we're working with kind of what we've got here at home at the minute. Hoping after Easter I'll have a few more bits and pieces that I can use. But if you make, there's your line, okay? As you make your line less steep to more steep, like that, okay, the measurement that has been taken in the vertical direction and the horizontal direction is changing. If you can see the end of the pen here, it starts off up here, and it's only about this far over, and as you make it less steep, it moves further along. Okay, similarly in the y direction, if you like, this is the y, this is the x obviously. As you make it more steep, okay, the gap in the y actually gets bigger, and the gap in the y gets less as you make it less steep. So it's all about how much is changing in the y direction and the x direction. Now, this line here, the y-axis, is known as, it could be known as the vertical axis, and this x-axis along the bottom here could be known as the horizontal axis. Okay, so essentially a gradient of a line, if I just draw a random line here, I'll make it not very steep, because most of the lines we would know, like on a road or something, wouldn't be all that steep. That'll be quite a steep line if you were driving a car up it. So we'll just use ones that are a bit more realistic. Here, the change in vertical, so from about there to there, that's going to be a change in vertical, and then the change in horizontal, okay, are going to give you a calculation that you can do. So if we knew, for example, the change in vertical was, let's say I knew the change in vertical was 2. It could be meters, could be anything, doesn't matter what the measurement is. And let's say the change in horizontal was 6. Okay, the way we could actually calculate the gradient, just move that up above slightly. If I could actually calculate the gradient, okay, I could do that by using this formula. It's a measurement of how much this is changing compared to this. It's how much the vertical is changing compared to the horizontal. So we literally would just have vertical divided by horizontal. Now, that's quite a lot to write out, okay? That's quite a large amount to write out every single time you do a question. So we want to shorten that. Now, fairly obviously, this side we can shorten to v over h, v for vertical, h for horizontal. Now, gradient, gradient doesn't become g. It doesn't even become G-A-R-D. The letter we use for gradient is m, okay? So you've now got this formula, and to be honest, this is the formula you're going to put a wee box around, and you want to try and memorize that. You want to try and learn that that is how you calculate actual gradients, and that'll give you a number. These are the values, and we can work it out. So, for example, if I go and do this question, there's my other boards. If I go and do that question, okay, on an actual bit of working, okay, so we're going to use that formula. And we're going to use the numbers from here. Okay, so if I had my solution, so you'd start off with m equals v over h. Okay, now we'll bring this just back in here. Here we can see that the vertical was 2 meters, the horizontal was 6 meters. So I'm going to go with 2 over 6. Now it's just a ratio really of what the vertical to horizontal is. So there doesn't need to be units at any stage really for when you're doing a gradient, but you would always simplify your fraction as normal. So we have a gradient here of 1/3. Okay, so that's a relatively mild gradient, not particularly steep. A different question might have a really, really steep line. and that number might be greater than 1, like 2, 3, 4, 5, etc. that we said at the very beginning, okay? So that's your basic ones. If it was something going in the other direction, so if it was something that was like this, so let's say we had a question which is like this, and we have sloping down the way, let's say a line like that, okay? Again, we're going to need some numbers on here. So there's your horizontal distance and there's your vertical distance. Let's say this was 10 and 10, because it looks to be actually pretty close to being that gradient. Now we know that, we can see that line's going down the way, okay? We can say that's a negative gradient. This is going to be a negative slope, so it's going to have a negative gradient. Now you won't be told that in the question, you'll just be asked, you know, find the gradient, or maybe calculate the gradient, okay? And your solution for this one would be the same as last time, so m equals v over h, but this time round you would include a negative, because you know and you can see that the line is sloping down the way. If you do exactly the same calculation, negative 10 over 10, and 10 divided by 10 is 1, so the answer to that would be negative 1. And it's just a sloping line going down the way. But this time round you're telling us that it's negative because you've calculated the gradient to be negative. Okay, now that's a wee bit longer than I wanted it to be. I want these videos to be quite short and sharp for small things. But then again, if I was doing a note in class, probably would take about 7 or 8 minutes to do, plus all the preamble at the start and the messing around me trying to get boards out and stuff. Does make this a wee bit longer, but I'll get quicker at it, because I don't want you guys to be sitting watching 20 minutes of a video just for something quite small and easy to do. Now, some questions that you can do here, okay? Now this is for National 5, so it's in the National 5 textbook. It's a wee bit of revision, technically it says at the start here, but you guys could be working on page 50. Okay, question 1, just even question 1 to 4 to start with. Now that won't take you very long, that'll probably take you 10 to 15 minutes to do. And then I'm going to have a part 2 video which takes you a wee bit further into actually using coordinate points. Okay, thanks very much everyone, see you next time.